Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. Okay. The slides are visible to you?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. So let us start with the today's lecture. So in the previous lecture, we have finished with the chapter number 3, unit number 3, that is transformations. That was having two-dimensional and three-dimensional transformations. And now we are going to start with the, yesterday we have started with the chapter number 4 also, clipping. So in that clipping, we have seen what is windowing and what is clipping. So we have seen with the example, windowing is nothing but the process of selecting part of real world scene to display it on some device. So whatever we are observing out of the window, or that is the real world, that is called as window, and the portion that we are going to clip from that nature, and we are going to paste it on our display device or physical device. It can be mobile, it can be laptop, it can be tablet, so whatever it may be. So that process is nothing but the process of extracting the portion is called as clipping, and the conversion from the window coordinate into viewport. So viewport is nothing but the physical device coordinate system where we are going to actually place the object. So that is called as viewport. So we have seen the basic definitions of window and clipping. So windowing is nothing but selecting the part of a real world scene to display it on some physical device is nothing but your windowing. Clipping or a clipping window, in short, it is nothing but the rectangular portion which is which checks the visibility of the object with respect to the window. So it checks whether the object is visible or whether it is not visible. So that is clipping window, and clipping is the process of deciding and removing the portion which is outside the window. So the portion which is inside the clipping window, that only we are going to take for display purpose. The remaining portion that we are going to discard. So discarding that portion which is not visible will save the amount of memory required to store that picture. So that is about windowing and clipping. Then we have seen this viewing transformation. It is nothing but converting the world coordinate system into device coordinate system. It is nothing but, or converting the image from window to viewport is nothing but your viewing transformation, or it is also called as windowing transformation. Then we have seen we can put the image, one image can be or this, that is a one window we are going to consider for this image which is showing the wall of the hut. So that can be displayed on the viewport at various locations, and we can have the ratio of height to width, that is the resolution as changing, or the size of the display device is changing, screen is changing. So you can have various representations of the same window on different viewports. So one can be horizontally stretched, other can be vertically stretched, depending upon the resolution and setting of physical device. So that is nothing but the uh, mapping with window to viewport. Then panning is again one of the mapping. But here in panning, we are taking the separate window for display purpose. So altogether, all pans will give me a complete picture idea. So that is nothing but it is focusing on the different portion of the real world entity. So here the windows are different and we are going to paste them on the different viewports as well. So windows are also different, viewports are also different. In earlier example, the same window is displayed on different viewports. So that is about panning. Then we have seen this conversion, that is in order to perform the viewing transformation, that is world coordinate system into device coordinate system. In that process, we are having two steps. First is you have to get the normalized transformation, and second is workstation transformation. So normalized transformation we have seen by using one by one block. We are going to compress the given image and we are going to make it to reside in one by one block. So it is going to reside in the one by one block, and then depending upon the workstation, so that is called as your normalized device coordinate system. And depending upon the workstation, if workstation is a tablet or if workstation is a laptop, so depending upon that, what we can say, depending upon the resolution of that physical device, we are going to convert it into appropriate physical device coordinates. So that is done in the workstation transformation. So these two steps will give you the shifting from world coordinate system into physical device coordinate system. So it is normalized transformation of one by one or unit block. Then we have seen this diagram where the this particular YV max, it is this point we are going to represent in the viewport. So it has the window coordinates represented with W, and it has the viewing coordinates represented with V. So we are showing the relation between the XV, YV and XW, YW. So we have come across the derivation part. So this derivation we have already studied in the yesterday's lecture. So this is nothing but the in earlier transformation, you are observing that Sx and Sy are the multiplying factor. That's why they are the diagonal elements according to the scaling. Then here xv min and yv min, they are added, and that's why these two are actually the kind of translation taking place. So here xv min and yv min, these are that represented in terms of translation matrix. Sy and Sx, they are represented in terms of scaling matrix. And the next is Yx mean and W mean. So here, these two are again represented as if they are translated. So addition and subtraction is nothing but the example of translation taking place. So here also we are having the translation matrix. So with this equation or with the multiplication of these three matrices, we can convert any object from world coordinate system into viewport coordinate system or physical device coordinates. So this much part we have seen in the yesterday's lecture. And then we are starting with the point clipping. So clipping basically has four types. First is point clipping, second is line clipping, third is polygon clipping, and fourth is text clipping. So we are having total 4 types of clipping. Out of that, you have only line clipping in your syllabus. Okay. So you are having the 4 types point clipping. So let us revise the definition of clipping. So what do you understand with clipping? Yes. Definition of clipping. Anyone? Okay. So clipping is nothing but removal of the portion which is outside the window and accepting the portion which is inside the window for display purpose. So we have seen the example earlier. If it is the kind of nature scene available, okay, this is the kind of nature scene available, and I'm going to convert this window into viewport. So for that, I am selecting the image, or we are going to select the window, which is called as clipping window here. So this rectangular portion, which is called as clipping window, is considered. And we will be having the portion which is inside the clipping window. So this is your clipping window. The portion inside this is some portion of the tree and the whole house. So I'm going to make use of this clipping window so that this picture will get displayed on my device. So clipping is nothing but extracting the visible portion and removing the invisible portion with respect to clipping window. So with respect to this rectangular clipping window, the portion which is visible is this small tree structure and the house. So remaining portion is getting cut and I am able to display this picture on my screen. So removal of the image which is outside the clipping window is nothing but your process of clipping. So what happens in the point clipping? What happens in the point clipping? So in point clipping, if the point is inside the window, then it is accepted and we are going to display that point. Procedure is same for anything. If point clipping is there, then we are going to check whether the point is visible. If it is visible, then we are going to accept it and display it onto the device. Else, if it is not visible, then we are going to discard that point or remove that point and it is rejected. So that is point clipping. If I'm considering line clipping, then all the things are checked with respect to the line, whether the line is visible. So if line is visible, then we are going to consider that line, else we are going to reject that line. So the process is same for any type of clipping. So in point clipping, we are having the if point is lying inside the window, then accept it and display it. And if the point is outside, then you have to reject it and do not display it onto the screen. So that is called as point clipping. So these are the conditions of the point clipping. Both the conditions should be true, then only the point is considered to be inside. So here P is a point with x comma y as xy coordinates. Here x min, y min and x max, y max are representing the boundaries of the clipping window. So there are four boundaries, or I can say the lower left corner and upper top corner, upper right corner. So that these 2 points will give you the complete rectangle, and that is your clipping window. So I am able to get this clipping window, and then I will check whether the point is inside or outside. So for that, P is considered having coordinates x and y. So I will check the value of x, whether x is in between min and max value of window. So window is having x min and x max value. Then I will check whether x lies in between. And that is the first condition, that x should lie in between x min and x max. And simultaneously you have to check for the y value. So y will also lie in between y min and y max. So if both the conditions are true, then only I can say that point P is lying inside the clipping window. So that point is considered for displaying purpose. Okay, so this much part we have covered, and now we are going to see this visibility of the point with respect to the clipping window. So let us draw the diagram here. We have to check the visibility of the given points 23, 38, 12, 27, 34, 56, and window left bottom corner is 20, 30. So I'm going to draw the window first, and then we will plot the points, whether they are inside, outside, that we will check. So the left bottom corner is 20, 30. So I will have this 1, 2, 3, 4, 5, 6, 7, 8. So these are the 10 to 10, 20, 30, 40, 50, 60, 70, 80. Up to 80, I have drawn the points. Then comes the y direction. Okay. So here also I am having 10 to 80. Okay. Now, the clipping window is having the lower left corner at 20, 30. So 20 is x value and 30 is y value. So it is over here. Next, 50, 50. So this is 30, 40, 50, 50, 1, 2, 3. 30, 40, 50. Okay. So this is 50, 50 point. Okay. So this is the clipping window, the rectangle, which is having the lower left corner 20, 30 and upper right corner 50, 50. So the window is with us now. Now we are going to plot A, B, C points and we will check. So depending upon the coordinates, whether it is possible for you to check whether they are lie inside or outside. So here 23, 38. So what is the condition for the point to be inside? So its x value should in between x min and x max value, and y value is also in between y min and y max value. So check, x value is 23. So what is the x of window? X is 20 to 50. So x is ranging from 20 up to 50. So first condition is satisfied. 23 lies in between 20 and 50. What about the second condition? The y value 38. where 38 is lying, it is also lying in between 30 and 50. So point A is considered as visible point. So it is going to check both the conditions. If both the conditions are true, then only that point lies inside. So I will have the representation of point A somewhere. So here is 20, 21, 22, 23 somewhere over here, and 38. So this is your 30 and 8 is near the 40 value. So here I am having the parameter A. Okay, and then I can say point A is visible with respect to the window because both the conditions are satisfied. X of point A is in between X min X max of window, and Y of point A is in between Y min and Y max of the window. So both conditions are true. That's why it is visible. Then what about point B? Point B, X value is not in between 20 and 50. 20 is your lowest X value and 50 is your highest X value, and 12 is the X coordinate. 12 is the X coordinate value of point B. So the first condition is not satisfying, that B is having less value as that of 20, that is the smallest value of the rectangle. So 12 is having still less value. Then what about the second criteria? 27. So Y value is 27. Whether that point will lie inside? No. Here both the conditions are not matching. 12 is not in between 20 and 50, and 27 is not in between 30 and 50. So this point lies completely outside. So I will draw that point 12 somewhere over here. X is 12, Y is 27. So 20 and 7 somewhere over here. Okay. So this point is point B and it do not lie inside because both the conditions are not satisfied. Now what happens with C? C value, X coordinate of C is in between 20 and 50. 34 lies in between 20 and 50. So half of the expression is true. Now check for the remaining half, Y value. So what is Y value? It is 56. So as Y is greater than the Y maximum we are having 50 and 56 is more than that of Y max. So this point C is outside the clipping window because only one criteria is satisfied. And to make the point visible, we should have both the criteria satisfied. Then only the point lies inside. So I will plot this point also. 34, first condition is matching. That's why this is your 34 point, 10, 20, 30, and 4. So 34 is the X value and 56 is the Y value. So here is the 30, 40, 50, and 56. Okay. So here I will have that C point. Okay. So C point is showing you one condition satisfied and other condition is not satisfied. Then also that point lies outside. Okay. So B is also not visible and C is also not visible. So that is the example of clipping, point clipping. Getting it?
Yes, ma'am.
Boys side?
Yes, ma'am.
Okay. So next point is line clipping. Uh, Wait for a second. Okay. Uh, so in the line clipping, before we start with the actually here line clipping is having two methods in your syllabus. First is the Sutherland-Cohen line clipping algorithm, and second is midpoint subdivision algorithm. So before we go to the Sutherland-Cohen line clipping algorithm, we will check the types of the line. Right. So first we will see what is line clipping. So line is a basic primitive as that of the point. Then while rendering a scene on the screen, user cannot display a portion of a scene which is outside the clipping window. So we are knowing that if the portion is outside the clipping window, then we are not going to display it on our device. Else we are going to cut it. The portion which is not visible, that we are going to cut that portion. And uh, that is called as clipping. So it is essential to determine which portion of the line is inside the clipping window and which portion lies outside. So finding out that uh, portion which is lying outside and inside is done with the help of clipping. So we will see the now the types of the lines. So for line clipping, the three types of lines are considered. First is if both endpoints are within the rectangle. So we know line has two endpoints. So if both the endpoints are lying inside the window, what is the meaning of it? Line has two endpoints, and if both the endpoints are inside, that means the whole line is inside the window. If endpoints are inside, then we are saying that the whole line is visible. So that is the first type of line, that is completely visible. So what it says, if both endpoints of a line are within, that is inside the rectangle or clipping window, then the line is completely visible. So the first type of line is completely visible line. Then the second is, and if this condition is not true, that means if both the endpoints are not inside, then the line can be partially visible or completely invisible, that is completely outside. So the second portion is telling you that if this kind of line is there. So with respect to clipping window, both the endpoints are outside the clipping window. Both the endpoints are outside the clipping window. So we are going to call this as completely invisible line. So here it is the completely outside or completely invisible line if both the endpoints are outside. But what is the partially visible line? So consider this example where both the endpoints are outside, but the line joining them is passing through the clipping window. So here the test, what test tells us? Both the endpoints are outside. But whether it is completely invisible line? No. Even though both endpoints are outside the clipping window, then also the line joining the endpoints, some portion of that line is passing through the clipping window, and that's why it is called as partially visible line. So there are three types of lines present. First is both the endpoints inside, then the whole line is visible. That is called as totally visible line, completely visible. Second is if both the endpoints are outside, then that line is totally invisible, it is completely outside. And the third parameter is though the endpoints are outside, then also the line joining the two endpoints passes from the window. So that is called as your partially visible line. So another way of partially visible line is one endpoint is inside and other is outside. So this type of line is also called as partially visible line. Okay. So these are the some types of lines with respect to the clipping window. Getting up to this?
Yes,
Yes,
ma'am.
ma'am.
Okay. Right. So here are the examples given. So line clipping, this AB line, both the endpoints are inside. That's why the line is totally visible. Then here CD line is, this is C point and this is D point. Both the endpoints are outside the window, and that's why it is totally invisible. And while these two lines, PQ and LM, they are having some portion inside and some portion outside, and that is why they are called as they are called as partially visible lines. So before clipping, you are observing, I will clear the screen. Okay. So this is the picture before clipping, and the next is after line clipping. So this CD line and the portion which is outside for PQ as well as for LM. So PQ line, some portion is outside, that outside portion is only eliminated. Similarly for LM also, it is partially visible line, and the portion which is outside the window is only eliminated. And here for the line CD, the whole line is outside, and that's why the line is eliminated. And that's why after line clipping, you are going to observe the pattern like this. AB is totally inside, so considered as accepted line. PQ partially, that's why both the endpoints are cut now, because both the endpoints are outside and some portion of the line is passing through the window. So only that portion is considered and endpoints are eliminated. And here for LM line, one endpoint is inside and other is outside. Okay, so that is called as your types of lines. And the portion which is visible with respect to window, that only we are going to consider. The portion which is outside, here the red line is having some portion outside, that has been eliminated. Okay, so now let us see what is the algorithm. So to clip the lines, so here in the above example, what we have done, we have clipped the line. Line clipping means what? Removal of invisible portion. So we have clipped the 4 lines in the above picture. 4 lines we were having, and we have done the clipping, that is by removal of the invisible portion. So how to achieve that line clipping? So it is done in 2 ways. First method is called as Sutherland-Cohen or Cohen-Sutherland line clipping algorithm, and the second method is called as midpoint subdivision line clipping algorithm. So 2 algorithms are there for the same task of line clipping. So let us learn the first algorithm, that is Sutherland-Cohen line clipping algorithm. So you can see the Cohen-Sutherland line clipping algorithm. It is a 2D line clipping algorithm and it operates in two phases. First phase is called as region code generation. So what is region code generation? So here the total screen, we are going to divide it into number of parts. So here the whole screen, or the window rather, that window is divided into 9 regions. So I will draw here the diagram of the window. Okay, so this is the whole window. Now this window is divided into 9 parts, and these 9 regions will have a separate 4-bit code for that specified area. So here total 9 areas are there, and I will have total 4-bit code for those 9 areas. In that, the middle portion is considered as the viewport where we are going to display the image. This middle portion is considered as the viewport or visible portion. The remaining portion is not visible. So I'm going to assign the number. So 0000, that is binary 40 number, is given to the display area, or we can say that this portion is nothing but your clipping window. So having code 0000. Now again, these 8 parts are having different end codes. This particular thing is called as region code or endpoint code also. So if the portion, if the region is on the left hand side of the screen, so this is your screen, or this is your what we can say is uh, clipping window. So if the portion is on the left hand side, so on this particular in this particular side, we are going to give the number. So we are going to set the 0th bit, that is nothing but the LSB. So we will set the LSB if the portion is on the left hand side of the window. Then if the portion is on the right hand side, we are going to set the second bit as 1. If the portion is at the bottom, then we are going to set the third bit as 1. And if the portion is above the top of this clipping window, then we are going to set the 4th bit or MSB equal to 1. Okay, so left indicates LSB, then top indicates MSB. So accordingly, we are going to specify the codes for those 9 regions. So how to assign the codes, that we will see in the next slide. And once that codes are assigned, then we will follow the clipping procedure. Okay, so in Sutherland-Cohen line clipping algorithm, first we are going to have the region codes for every region. Out of that, the middle portion is considered as the center of the 9 codes, or it is also called as the clipping window. So it has a code of 4 zeros. So in the next slide, we are going to see how to give numbers to those 8 remaining areas. So see here, in region code generation, the plane is divided into 9 regions. So we have divided the plane into 9 regions. It uses the out codes, or it is also called as endpoint code, or it is also called as region code. So 3 names are there: out code, or endpoint code, or region code. It uses the out code to determine visibility portion of a line. So it will determine which portion is visible. So this out code is a 4-bit binary number. Out code is a 4-bit binary number. So it has the value as 0 and 1 only, and that too a 4-bit number. So here the value of bit is set to 1 if specified condition is true for a particular bit. Specified condition is true. So here the first bit. So these are the 4 bits. These are the 4 bits of the out code. Out of that, I will check for the y value. So if y value is greater than maximum y, then you have to set the top value equal to 1, else you have to make it 0. Okay, so here I'm going to consider top of the uh, uh, top of this particular window. Then I am going to set this first bit as 1. So I am going to set the first bit as 1. Now what about the remaining 3 cases? Here Ymax and Ymin, these are nothing but I will show you with names. So this is your X mean, because these 2 points are your uh, bottom left corner, or bottom left and top right corner. So it will specify the maximum and minimum X and Y values for this particular region. So I will have here X min value. Here I am having X max value. Here I am having Y min value. And here I will have Y max value. Okay. Just wait for a second. Okay. So here is the total plane is divided into 9 regions. Out of that, the central portion is having 4 zeros, which represents the clipping window. And depending upon the position of the remaining 8 regions with respect to this clipping window, we are going to set the bits as 1 or 0. So here it is considered as if the portion is on the left hand side. So this clipping window is having coordinates lower left corner as x min y min and upper right corner as x max y max. So these are the two coordinates which will give you the rectangular window. Now with respect to this clipping window, I am going to set the bits. So if the y value is greater than y max, so in this region, the y value is greater than y max. So y max is here. So if the y value is greater, then I'm going to set the first bit is equal to 1. So the first bit I'm going to set as 1. Now, whether the y value of this region is less than y min? No. The y value in this region is greater than y max. So it will not be less than y min. So the second bit has to be 0. Then what about x value? So in this particular region, the x value lies in between x min and x max. Right? All the x values in this region, if I consider this particular point, this point is having x value in between x min, x max. So it is neither greater than x max, nor it is greater than x min. So I will have the code for this region as 1000. So this first bit is set to 1. The remaining 3 bits are 0. Because these 3 conditions are not satisfied. All of you are getting this, how we have got this code. Yes. Yes, students. Or shall I repeat it again?
Understood, ma'am.
Hello, girls. I'm not able to listen. What? Just tell me whether I should repeat this.
Ma'am,
Your voice is not clear. So can you?
Yes, ma'am.
ma'am, repeat.
Okay, I will repeat. See, what we have to do is we have to in earlier example. I will show you. Okay. Right. Right. So in this example, what we were observing, this white portion is considered as your clipping window. This white rectangle is considered as your clipping window. And then we are going to reject the portion which are outside. We are going to reject the portion which are outside the window, right? So here I am going to consider the x min and x max of this window. So this portion, this is the lower left corner. It is having the coordinates as x min, y min. This lower left corner is having x minimum, y minimum value. And this upper right window, upper right corner is having the coordinates as x max, y max. Maximum x and maximum y value. Okay. So this is your clipping window. Now I'm going to check the portion which is lying outside. So for that purpose, I will assign the numbers to the areas which are around this clipping window. मी काय करणार आहे ही clipping window आहे. So around this clipping window, whatever the area is available, I am going to divide it into number of regions. And depending upon the location of that region, I will assign some code to it, a 4-bit code, or it is also called as out code. Okay. Up to this, is there any difficulty?
No, ma'am.
Getting it? Okay, right. So now this complete whole region or this whole plane, I'm going to divide it into 9 regions. Out of that, this white portion is having the code as 0000. That means our clipping window is having code 0000 that is in the center. Now all of you are understanding? This whole window, which is the clipping window, is present at the center, and it is surrounded by the plane. It is surrounded by the 8 regions. So those 8 regions, we will assign some code to them, because to the window we have assigned 0000 as a 4-bit binary out code. So all these regions also I will specify some codes so that I can use those codes to check whether the line is totally visible, partially visible, or totally invisible. Okay, now all of you are getting?
Yes, ma'am.
Okay, girls.
Yes, ma'am.
Okay, so in this particular area, I'm going to assign some codes to them. So in short, if the area is on the top of the window, this is your window and this particular area is on the top of the window, right? So if the area is on the top of the window, then I will set this first bit as 1, remaining all will be 0. Okay, so you remember it like that. So if we are having the area which is on the top of your screen or top of your clipping window, then I will make the MSB, the most significant bit, equal to 1. Remaining 3 bits will be 0. Then I will have the left hand side of the window. So this is your window and you are having the left hand side of the window. So on this left, the if your region is on the left hand side of the window, we are going to set the first bit, that is the LSB, equal to 1, and the remaining 3 bits will be 0. Okay, so if the area is on the LHS left hand side, then set the code as 0001. Next, if the area is on the right hand side, then set the code as 0010. Meaning is, if the code is 0010, that area lies on the right hand side of the window. And if it is at the bottom of your clipping area, then set the third bit, that is, we will set the code as 0100. Getting now? So we are assigning these codes, which is based on our criteria for the region code. So these are the 4 region codes given to the 4 areas: left area, top, right, and bottom. Okay, left, top, right, and bottom. So these codes are given. Now what about this region? What about this region? What is the relationship of this region with the clipping window? Clipping window च्या कुठल्या साईडला आहे हा? तर this corner is at the top of it as well as on the left of it. This portion is present above the clipping window, and as well as this portion is on the left of the clipping window. Then for top and left, What are the conditions? First and last bit is 1. So this portion is having first and last bit as 1. The remaining 2 bits will be 0. Getting it now?
Yes, ma'am.
Boys side?
Yes, ma'am.
Okay. Now what will be this region code? This portion is on the right hand side of the window, the relation between the clipping window and this region. So this region is on the right hand side as well as on the top. So top and right are having second, that is first and third bit as 1. So first bit is 1, third bit is 1, remaining 2 are 0, 0. Similarly, I will write the codes for these two bottom entries. So what is the relation between this area and the clipping window? So this area lies at the bottom as well as left. So bottom and left, both the combinations are there. So this is your bottom code. This is your left code. So both are mixed together. So the first, second, third, fourth. So second and fourth bit is 1 and remaining 2 are 0. Okay. And for this particular region, this region is on the bottom and right hand side. So bottom and right is having second and third bit set. So I'm having 0, 1, 1, 0 code for this region. Now all of you are getting this?
Yes, ma'am.
Okay. So we have divided the whole plane. हे जे whole plane होतं, that we have divided into 9 regions, which has the region outcode from 0000 to 1001. So 0 to 9. Total these codes, or rather 0 to 10, 1010 is the highest number assigned to it. So these are the codes given to the specified area. Okay, so that is called as your first step of the Cohen-Sutherland line clipping algorithm, which is called as region code generation. So now we will see that slide where okay, that slide where actually it is written in terms of some. Okay, so the steps of the Cohen-Sutherland line clipping algorithm is region code generation and clipping procedure. So out of that first step we have seen now. So region code generation. So let us read it again so that it will be more clear to you. It divides the plane in 9 regions. So these are the 9 regions the plane is divided into. It uses the outcodes to determine the visibility portion of a line. So these are the outcodes, which is a 4-bit number, 4-bit binary number. And using these outcodes, we are going to check whether the line portion is visible or not. Then the outcode, it is a 4-bit number. Yes, we have already seen that. Then the value of bit is set to 1 if specified condition is true for the particular bit. So if the window top is there, so window top means this bit is set, that is your first bit. So y is greater than y max. So this is your y max line and your y is greater, and that's why it is set to 1. So you can see for this region where y value is greater than that of y max, then all has their first bit set. Then second is window on the bottom. So all the bottom windows having this second bit set. So if y is less than y min, so this is your y min line, and y is greater than y max, then all has their first bit set. Then second is window on the bottom. So all the bottom windows having this second bit set. So if y is less than y min, so this is your y min line, and y is greater than y max, then all has their first bit set. and below that whatever are present, all are having their uh, second bit set. So you can see here second bit प्रत्येकाचा set आहे because this y is less than y min value. So this condition is satisfied over here. So y is greater than y max. पहिल्यांदा बघितलं. So first bit is set for all. Then y is less than y min. तर second bit set झालेलं आहे. Then जर राईट हँड साइडला असेल, विंडो इज प्रेझेंट ऑन द राईट हँड साइड. राईट हँड साइड म्हणजेच काय असेल, मॅक्स एक्स मॅक्स पेक्षा पण एक्स जास्त असेल, ग्रेटर असेल, ग्रेटर दॅन एक्स मॅक्स आहे. सो यू हॅव टू सेट द थर्ड बिट इक्वल टू 1. सो दिस इज युअर एक्स मॅक्स लाईन अँड एक्स मॅक्स पेक्षा जास्त असेल तर थर्ड बिट इथे सेट झालेलं आहे. सो आय एम सेटिंग द थर्ड बिट. And if x is less than x minimum, if x is less than x minimum, then the fourth bit is set, that is LSB. So fourth bit is set for this region where x min पेक्षा पण x ची value जर लहान असेल, x is less than x min, so left hand side part. So for that regions I am having the LSB set. Getting it? So this is how we are going to give the codes to the all regions around the clipping window. Getting it now?
Yes, ma'am.
Okay. So and clipping window is having the outcode 0000. So that is how we have assigned the codes to this region. So first step is over. That region code generation we have completed, region code generation. After that, the second step is there. And what is the second step? So see here, the window codes that we have generated are same. So in short, you have to remember this TBRL. These are the 4 bits. If window is on the top, then first सगळे bit 1 आहेत. पहिलं bit is there in 4-bit number. First bit is there for the top portion. Second bit is there for the bottom portion. Third bit is there for the right hand side portion, and fourth bit is there for left hand side portion. So TBRL that you have to remember, so that it will be easier for you to draw these 4 codes, these 9 codes rather, 4-bit. Okay. So first step is over. We have assigned the outcode to every portion on the plane. Now next is step number 2. Now we will start with the clipping procedure. So in this clipping procedure, there are 3 steps or 3 cases. First is if both endpoints are inside the clipping window. What will happen if both the endpoints are inside the clipping window? Yes, can you tell me? If both the endpoints are inside the clipping window.
Completely visible.
Yes, so the line is completely visible. For example, this is your clipping window having the end code 00, and I will have a line like this. I will have the line like this. So in that line, you can see that the line is totally inside. So if both the endpoints are inside the clipping window, then entire line is visible and it is accepted. So it do not require any clipping. When clipping is required, if some portion is outside, then only we have to cut that portion. If no portion is outside the window, then whether clipping is required? No. The line, there are three cases. This is the first case, this is second case, and this is third case. And we will see one more. This is fourth case. Okay. So when clipping is required for this line, I will call it as line A. For this line, whether the clipping is required? No, because
Ma'am,
the whole line is inside. So we cannot, or we don't require any clipping method. Similarly, for line B, whether the clipping is required? No, because the whole line is outside. So we don't want any cutting of the line, or clipping procedure is not required over here. So directly we are going to reject this line as it is outside. If it is completely inside, then we are going to accept that line and then we will stop. If completely outside, then we will reject that line and then we will stop. But when the line is partially visible, when some portion is inside and some portion of the line is outside, when these conditions are true, then only we require the clipping method, that we should eliminate the portion which is outside. We should eliminate this portion. We should eliminate the portion which is outside and keep only this much portion visible. Similarly, for this line also, we should keep this portion as visible and remaining portion we have to cut. Okay, so that is how clipping is required only for partially visible lines. If line is totally visible, no clipping required. If line is totally invisible, then also no clipping is required. So let us see the three types of cases. First case is if both endpoints inside, case A here. So the entire line is visible and it is accepted and no clipping required. Case number 2, the case is for this line B. If both endpoints are completely on one side of the window, completely on one side of the window, both the endpoints are there, which is completely on one side of the window, then also we don't require clipping. The line is totally rejected as it is completely outside. So it is completely outside the window and hence rejected. So no clipping is required here also. And in the case 3, both endpoints are outside, but line goes through a window. We have seen the example. Both endpoints are outside, but line is passing through the window. Right? This is the example. Endpoints are outside, but line is passing through window. Or one endpoint is outside and other is inside. So one endpoint is outside and other is inside. So this is the example. Then in both the cases, the line is partially visible. In both the cases, line is partially visible and hence we require clipping. Okay. Getting up to this?
yes, ma'am.
Both side?
Yes, ma'am.
Okay. So let us see now the actual clipping. Okay. So clipping can be done, or checking of these three cases is done first. So first we are going to check the cases in the programming language. So first is we are going to perform the OR and operations. So logical OR and operations we are going to do. So case number 1. So the line is completely visible if logical ORing of outcode is 0, 0, 0, 0. So end points of the line. So this same example I will take, that the point A or this line A is having two endpoints which are lying inside the clipping window. So what are the outcodes of these two endpoints? This is also having the outcode as 0, 0, 0, 0, and this is also having 0, 0, 0, 0, because both points are lying inside the window, inside the clipping window. So both are having the encodes as 0, 0, 0, 0. Now when I perform the logical ORing between these two, how to perform logical OR operation? If any one of the input becomes 1, then the output is 1, else the output is 0. Right? So it is same as that of your OR gate. So here I will get the OR operation of this endpoint. The result is all zeros. So it is the case number 1, that the line is completely visible. For checking this condition, completely visible line ची condition काय आहे? जर logical ORing of outcode is 0, 0, 0, 0. Logical ORing of outcode of both endpoints, endpoint number 1, endpoint number 2. If both the endpoints are having the ORing as 0, 0, 0, 0, then the line is totally visible or completely visible. Okay, so that is your case number 1. Then case number 2. So second case is if logical OR is not 0, 0, 0, 0. Logical OR जर 0, 0, 0, 0 नसेल, then there is possibility either the line is partially visible or totally invisible. For example, this line. What are the endcodes? The portion, the point which is inside will have the endcode as 0, 0, 0, 0. And in this region, the left hand side region, the end code is 0001. For this region, the end code is 0001. Now when I will perform the ORing of these two numbers 0000 and 0001 now, if I will perform the ORing, then I will get a result as non-zero. So if logical OR of two outcode is non-zero, then there are two possibilities. This first possibility is the line is partially visible. Line is partially visible like this line. And second is the line is totally invisible. Now we will see the endcodes of this line B. What are the endcodes of this line B? Can you tell? Endcodes of line B. It is on the bottom of the window. So this region. Bottom of the window means this region 0100. So this code is 0100. Similarly, the second code is also 0100. So when I will perform the ORing between them, जेव्हा मी दोन्हीचं OR करते तेव्हा मला काय मिळतंय 0100 हा रिझल्ट मिळतोय, which is a non-zero, and that's why the line is completely outside. Okay, all of you are getting this? Up to this, is there any difficulty?
No, ma'am.
Okay. Now my question is, this result number 1 and this result number 2 both are non-zero. If the result is 0, then we are saying that the line is totally inside and totally visible. But in case number 1 and case number 2, both are giving non-zero values. Then how to check whether it is partially visible or completely invisible? कारण ह्याच्यामधली एक लाईन आहे ही बी लाईन आहे ती कम्प्लिटली इनविजिबल आहे आणि ए लाईन ही जी लाईन आहे ती पार्शियली विजिबल आहे. मग आता त्या दोन्हीमध्ये डिफरन्शिएट कसं करणार तुम्ही? कारण रिझल्ट तर दोन्हीचे रिझल्ट तर तुमचे नॉन झिरो येत आहेत. गेटिंग द क्वेश्चन? These are two different types of line. एक लाईन आहे C line which is partially visible and B line which is totally invisible. ही totally outside आहे, ही partially outside आहे. पण दोन्हीचे रिझल्ट काय येत आहेत? नॉन झिरो. मग तुम्हाला कसं कळेल जर नॉन झिरो रिझल्ट आल्यानंतर whether that line is partially visible or it is totally outside? And for that purpose, now we are going to have the ending between the end codes or region code. So first मी काय केलं? OR operation केलंय. Using OR and operations, we are going to check the visibility of the line. So first OR operation करून बघितलं. जर OR operation नि रिझल्ट 0 येत असेल तर टोटली विजिबल आहेत. जर नॉन झिरो येत असेल तर दोन रिझन्स असू शकतात. एक कम्प्लिटली आउटसाइड आहे किंवा पार्शियली आउटसाइड आहे. आणि मग आता या दोन मध्ये डिस्टिंग्विश करण्यासाठी परत एक मी चेक लावणार आहे ह्याला. परत एक मी स्टेप वाढवते विच इज कॉल्ड एज युअर एंडिंग लॉजिकल एंड. ओके, सो नाउ आय विल डू द लॉजिकल एंड. सो पहिले ऑपरेशन OR ऑपरेशन झालेलं आहे. आता लेट अस सी फॉर लाईन C what is the AND operation. Now I will do the ending between these two values 0000 आणि 0001. ह्याच्यामध्ये मी जेव्हा AND ऑपरेशन परफॉर्म करते तेव्हा रिझल्ट मला काय मिळेल? सो व्हॉट इज द प्रॉपर्टी ऑफ AND ऑपरेशन? येस, AND ऑपरेशनचं काय प्रॉपर्टी? जसं OR ऑपरेशनचं कुठलंही एक इनपुट 1 झालं तर आउटपुट 1 असतं, तसं ANDचं काय असतं? जर दोन्ही इनपुट 1 असतील तरच तुमचं आउटपुट 1 येतं, अदरवाइज इट इज 0. ठीक आहे. सो व्हॉट विल हॅपन? दिस इज युअर वन एंड पॉइंट अँड दिस इज युअर अदर एंड पॉइंट विच इज आउटसाइड. जेव्हा मी एंडिंग करते तेव्हा काय होईल? 0 आणि 1चं अँड 0च येईल. बिकॉज जेव्हा दोन्ही इनपुट 1 असतील तेव्हाच फक्त आउटपुट 1 येतं, अदरवाइज इट इज 0. So I am getting the result as 0000. AND operation for the end codes of C line. Now we will see what happened with B line. B line चे end code काय आहेत? 0100 आणि 0100. So I will perform the ending between these two. So 00 will give you 0. Now 1 and 1. So when both the inputs are 1, then the output is 1. So you can see now, if the AND result is giving you all zeros. आता मी डिफरन्शिएट करू शकते दोन्ही मध्ये. जेव्हा एंडिंगचा रिझल्ट मला ऑल झिरो देतं तेव्हा मी त्याला म्हणेल पार्शियली विजिबल लाईन. सो PV stands for partially visible. And if the ending gives you again the non-zero result, then it is totally invisible line. So TIV stands for totally invisible. Okay, so that is how we can differentiate between these two. Line B and line C. Okay, so let us read these 2 points. If logical ending of two outcode is non-zero. So here the example is this. the logical endingचा result is not 0, then the line is outside, so completely invisible. And if the ending result is 0, 0, 0, 0, like this, then it is partially visible line. So partial visible line is when the result is all zeros. Getting it now?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay. Right. Thank you. So let us see now the algorithm for this. So now what we have done, we have determined whether the lines are totally visible, totally invisible, or partially visible. आतापर्यंत फक्त आपण हे डिटरमाइनच केलं की लाईन चा टाइप कुठला आहे आणि आता ऍक्च्युअल आपण क्लिपिंग करणार आहोत. एकदा कळलं की लाईन कुठल्या प्रकारची आहे तरच मी क्लिपिंगला पुढच्या स्टेपला जाऊ शकते. जर ए प्रकारची लाईन असेल तरी क्लिपिंग नाही लागणार, बी असेल तरी क्लिपिंग नाही लागणार, फक्त सी टाईपची जर असेल तरच वी विल डू द क्लिपिंग. सो लेट अस सी हाऊ टू क्लिप. सो we will see the clipping in this case. So if line is neither accepted, that means not totally visible, nor rejected, means not totally invisible. या दोन्ही केस नसेल तरच it is partially visible. So we need to compute the intersection point of line with clipping edge. So for the partial line only, what now we have to do is we have to find out the intersection point of line with the clipping edge. So line and this clipping edge चा जो intersection point आहे तो मला find out करायचा आहे. का? Because this is the last point that is visible. Because it is present on the screen, so it is the last point or farthest point which is visible as far as the clipping is concerned. Okay, so I will find out this intersection point. Now how to find out the intersection point? For that I will consider the formula of the slope, because slope of the line is going to remain constant throughout the line. Slope of the line is constant throughout the line. In between any 2 points मी जर slope घेतला तर तो सेमच येईल. So these endpoints are considered the endpoints as x1 y1 and x2 y2 असे असतील. Then I will calculate the slope by using the formula y2 minus y1 divided by x2 minus x1. So I will use this formula, and then once I will have this calculation of m, एकदा m मिळालं, then I know the coordinate, one coordinate of this point, intersection point. Which coordinate I know? I know this x value as it is lying on this vertical line. Its x value I know, that is your x mean of window. कोणतीही साइड घेतली तरी तुम्हाला इथे असेल तर x मीन मिळेल. या साइडला जर इंटरसेक्शन असेल, जर लाईन अशी असेल तर या साइडला जर इंटरसेक्शन असेल तर त्याचा कोऑर्डिनेट x मॅक्स असणार आहे. जर या लाईनवर असेल बॉटम लाईनला तर त्याचा इंटरसेक्शन पॉइंटचा y व्हॅल्यू माहिती असेल, विच इज युअर y मीन व्हॅल्यू जर या लाईनवर असेल तर, आणि जर टॉपच्या लाईनला असेल तर दॅट इज युअर y मॅक्स व्हॅल्यू. ओके, सो एकदा मला स्लोप मिळाला तर स्लोप बिटवीन दिस एंड पॉइंट्स इज सेम एज दॅट ऑफ दिस अँड इंटरसेक्शन पॉइंट. मग मी काय करणार आहे, एकच पॅरामीटर अननोन राहील. एक्स मीन माहितीये मला, या पॉइंटचा मला y फक्त फाइंड आउट करावा लागेल. So while solving this expression of m, I can easily get the y coordinate at this place. I will get the y coordinate at this particular place. Okay, so first I have to find out the slope by taking the end points. आणि तोच स्लोपचा व्हॅल्यू वापरून जी काही व्हॅल्यू येईल स्लोपची तीच वापरून मी इथला सी च्या म्हणजे इंटरसेक्शन पॉइंट फाइंड आउट करणार आहे. त्याचा एक्स व्हॅल्यू एक्स मीन आहे. सो आय विल फाइंड आउट द वाय व्हॅल्यू बाय युझिंग स्लोप फॉर्म्युला. getting and that point is farthest visible point. त्या पॉइंटच्या पुढचे सगळे पॉइंट तुम्ही डिस्कार्ड केले तरी चालतील and that is called as your clipping. कळलंय सगळ्यांना?
हो मॅम.
Yes. So we will solve one problem on it and then you will have more clear picture about it. So let us solve the problem with this. So these are the steps. Step 1, for any problem solving or even writing the algorithm for this Sutherland-Cohen line clipping algorithm, these are the steps you need to follow. So step 1 is x min y min हे विंडोचे कोऑर्डिनेट आहेत क्लिपिंग विंडोचे. x min y min रीड करायचंय, x max y max रीड करायचंय and draw the window. ही पहिल्यांदा विंडो ड्रॉ करून घ्याल तुम्ही. नंतर सेकंड काय, लाईन्सचे एंड पॉइंट्स बघायचे ते x1 y1 x2 y2 बिकॉज वी वॉन्ट टू क्लिप अ लाईन. आता एकदा विंडो ड्रॉ झालेली आहे, मग एक लाईन ड्रॉ करूयात which is having the coordinates x1 y1 x2 y2. Then compute the outcodes around the window region. प्रत्येक साइडचा आउटकोड कम्प्युट करायचंय आणि तो आउटकोड कसा कम्प्युट करायचा ते आपण बघितले. TBRL, that is top, bottom, right and left. सो तसे सेट करून बिट्स आपल्याला मिळणार आहेत आउटकोड्स. Then step number 4. So this is for x1 y1 and x2 y2 that you have to get the outcode. And then you have to perform first OR operation. जर दोन्ही एंड पॉइंट्स OR 0 0 0 0 असेल तर काय OR operation. End points of the line, त्याचं जर OR operation 0 0 0 0 आलं तर that is your step number 1. So line is accepted and you have to stop. Okay. OR operation ni जर 0 0 result दिला इथे ही line A, OR operation giving you the result all zeros. So line is accepted, then stop. Second case is if OR operation ni तर आता एकच टास्क करायचं होतं, तर नेक्स्ट ऑपरेशन आहे ते AND ऑपरेशन आहे. So you are going to check whether the AND operation between the A and B outcode end जर नॉन झिरो असेल. सो नॉन झिरो म्हणजे काय, ही केस ऑफ लाईन B. जेव्हा त्याचा रिझल्ट ऑफ AND ऑपरेशन इज नॉट 0 0 0 0, then that line is rejected and we can stop. else मध्ये काय येतंय, else मध्ये येतंय this particular portion where the line is partially visible. So you have to compute the intersection point of line with the boundary of the window. So once we get that the line is partially visible, then we will find out the intersection point and intersection point of line with the window edge. And then we will discard the remaining portion. Okay. Understood all of you? The algorithm steps. Yes. Reply, students.
Yes, ma'am.
Okay. Girls.
Yes, ma'am.
Okay. So let us solve the problem now. Okay. So let us solve this problem. Clip a line AB with A value दिलेला आहे, B value दिलेला आहे. So these are the two endpoints of a line. And you have to use Sutherland-Cohen line clipping algorithm with window coordinates, these two. Window coordinates दिलेले आहेत. So what are the steps of the algorithm? Steps काय होते algorithmच्या? First step होती x min, y min, x max, y max read करा and clipping window draw करा. So these are x min, y min, x max, y max. हे window coordinate आहेत. So I am reading those 4 coordinates and I will draw a clipping window. So coordinates आहेत -1, 3. It's about x. Y. Okay. So this point -1, 3. So this is your -1 and 3 is 1, 2, 3 over here. This is lower left corner of the window and 2, 6. So 2 is here and 6 is somewhere over here. Okay. So this is giving you okay. So that is how the window is drawn. Okay. All of you have understood this -1, 3 and 2, 6. Is there any difficulty?
No, ma'am.
Okay, so step number 1 is over. Now in the step number 2, they told us to read the endpoints of the line now. आता line चे endpoints read करायचे and then we have to draw that line. So line is having endpoint -1, 5. So x value is -1. This is 3, 4, 5. So -1, I will draw separate color. Okay. So this is -1. This is 3, 4, and 5. So this is the point. And second is B 3, 8. So this is 3 and 7 and 8. Let us see. Okay. Right. So I'm going to have 3 comma this is 6, 7 somewhere, and 8. Okay. So I will extend this line, y coordinate. This is your 7 number, and this is 8 number. Okay. So you have got the line like this. Okay. -1, 5 to 3, 8. So these are the two endpoints, point A and point B. Okay, so line is also completed. Now next, you have to give the end codes, because now once you give the end code, you can check whether the line is partially visible, totally invisible, and what next steps. Okay, what are the next steps? So for this line AB, we will find out the end code for A and B. So can you tell me the end code of A? End code of A. A is lying on the border of the window, and that's why it is having exactly the X value same as that of your X minimum, and that's why this A is having end code 0000. It is considered as inside point. Now what about B? B. What is the relation of B with the window? Can you tell me what is the relation between window and B? So I will extend this. Now can you tell me in which region this B is present? This is your window region with end code 0000. Now here the point B is lying over here. Can you tell me the end code of point B?
1010.
Right. So it is on the top as well as on the right. So 1010. Top indicates this one and right indicates the third one. T, B, R, L. Top, bottom, right, and left. So top and right is having end code as 11, and bottom and left having 00. So this is having. Now, according to the step number 1, we are going to perform the OR operation between these two. So what is the result of OR operation? The element is having value 1, and that's why I am getting the result as 1010. So as the result is non-zero, the line is either partially visible or it is totally invisible. So let us see what is true. So OR operation is giving me non-zero result. So I have to perform the AND operation between them. OR ni मला काय मिळालंय? Non-zero result मिळालाय. Non-zero result is the case or possibility of two different cases. Line is partially visible and line is totally invisible. Now I will check the AND between these two. So what is the result of AND operation I am getting? AND operation is giving me result as 0000 because कोणतंच एलिमेंट असं नाहीये की ज्याचे दोन्ही इनपुट्स 1 होतील. इथे 1 आहे तर इथे 0 आहे, तसंच इथे 1 आहे तर इथे 0 आहे. Remaining all are already 0. So AND is giving me the result 0000. It means the line is partially visible. Okay, the line is partially visible. मग जर partially visible line असेल तर मला काय करायचंय? I have to perform the clipping. You have to go for clipping. मग clipping कसं करणार आहे मी? I am going to make use of slope formula. So what is the formula for slope? Slope is y2 minus y1 divided by x2 minus x1. Okay. So can you tell me the slope now by putting the values of x1, y1, x2, y2 like this. So y2 is 8 minus y1 is 5 divided by x2 is 3 minus x, this is x2 minus x1, right? Okay, so I'm getting 8 minus 5, 3 divided by 4. All of you are getting up to this?
Yes, ma'am.
Boys side?
Yes, ma'am.
Okay, so slope मिळालाय मला, slope is 3 by 4. Then by using the same slope, I can find out this intersection point. आता काय करायचंय मला? हा intersection point find out करायचंय. Because it is the intersection point. Right? This is the intersection point because this A is already visible. And this intersection point only I have to find out so that I can remove this portion of the line. Now how to find that? So for that I have calculated the slope. Now in the same formula, I will put the value of A and that particular point. So I will call this point as x comma y. I will call this point as x comma y. So can you tell me now which value is known to you? Which value is known to you? हा इंटरसेक्शन पॉइंट आहे, हा एका विंडो एज वर आहे ऑब्विसली, कारण लाईन आणि विंडो एजच आपल्याला इंटरसेक्शन काढायचंय. सो हा पॉइंट, this point is lying on one window edge. This window edge is having the y max value. What is y max then? Maximum y is 6. हा पॉइंट आहे तुमचा x min y min आहे आणि हा पॉइंट आहे तो x max y max आहे. त्यातला x max हा इथे आहे तो 3 आहे किंवा 2 आहे, सॉरी हा 2 आहे आणि y max काय 6 आहे. So I have this y value of this point. Current window edge is intersecting the line at y equal to 6, y equal to y max. So I am having x coordinate unknown आणि y मात्र 6 आहे हे मला माहिती आहे इथल्या इंटरसेक्शनचा. So I will put this value in the formula. So I will calculate the intersection point. I will name it as I. So I will take the slope of B and I. So in the slope, I will put the formula, I will put the values of B and I now. So B having Y value as 8. Then I is having Y value as 6. Divided by B is having X value 3 minus I is having X value as X only, X coordinate as X. Now slope is already known to us. What is the slope value? 3 by 4. So I will solve this equation now. So performing the cross multiplication, I will have 3 into this expression. 3 into 3, that is 9 minus 3x is equal to 8 minus 6, 2 into 4, 8. So this 3x I will move this side and 8 I will move this side. So 3x is equal to 9 minus 8, that is 1. So x equal to 1 by 3. So we can see that 1 by 3 is nothing but 0.3, 0.334 like that. So I can see here x value the intersection between the window and the line is having x value. X value is 1 over here. So it is somewhere over here. So that is your intersection point. Having x value at 0.3. So I am going to remove the line from this point of intersection to this point B. So I am going to eliminate this and I am going to display only A to I line. So this is achieved with the help of Sutherland-Cohen line clipping. Getting it? Yes, students?
Yes, ma'am.
Okay. Boys side?
Yes, ma'am.
Okay. So I will rub all these things. So one method we have studied, that is how to clip a line by using Sutherland-Cohen line clipping algorithm. The second method is called as midpoint subdivision line clipping algorithm. So the name itself suggests that we are going to subdivide the line until the midpoint and the intersection point coincides. For example, the midpoint subdivision algorithms works in this manner. Consider this is a partially visible line. So I will divide it at its midpoint. So I will divide the line at its midpoint. So this is your midpoint, let us assume. Now I will check whether, suppose the line is A, B, then I will check whether M1 is partially, whether M1 is inside or outside. So as M1 is inside, that means AM1 and BM1. Now I will divide the line into two segments, AM1 and BM1. Then again, I will divide the line at its midpoint. So AM1 is divided here. And I will get AM2. So M2 is the midpoint of AM1 again. Then I will check whether AM2 is totally visible or totally invisible or partially visible. If it is partially visible, then go on repeating the procedure of finding midpoint, right? So same way, the remaining half part also. So for BM1, I will divide the line at its midpoint. This is your M3. Now, by checking the BM3, I will find that BM3 is totally outside. So I will remove that portion and I will concentrate on M1, M3 now. So M1, M3, again, I will divide the line at its midpoint. And that midpoint is M4, suppose. Now I will check M3, M4 line. This is totally outside. So I will remove that and I will see that M1, M4 line, which is inside. Similarly, this AM2 is also outside. So I will cut that portion. And in that way, after multiple subdivisions at midpoint, I will get the line M2 to M4, which is the visible portion only. Right? So what we are going to do is, for a partial line, we are going to subdivide the line at its midpoint recursively. Recursive subdivision, and every time checking the two chords, whether they are inside or outside. Right? So if they are inside, accept them. If they are outside, reject them. If they are partially visible, then again go on subdividing the line. So this process is repeated. Okay, getting the principle behind this midpoint subdivision algorithm. Yes, students.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Right. So here also two steps are there, like that of Sutherland Cohen. First, region code generation, same as that of earlier algorithm. It computes the outcode of a line endpoints and determines intersecting side of clipping region with the line. And second is clipping procedure. For partially visible line is subdivided into two halves and processed both halves recursively. So both the half part we are going to process recursively. If subpart of line becomes fully visible or fully invisible, stop. Otherwise, again recursively go on subdividing the line to find its midpoint. Right? So that is how the steps are carried out. So first, always there region code generation to check the type of the line, partially visible, then totally visible, totally invisible. So here also logical OR and same steps are there. First is the logical OR operation giving you 0, 0 means full visible line. Then OR operation is not 0, 0, 0, 0. Then two things, completely outside or partially outside. So perform AND operation. Then AND operation is not 0 means reject the line. If AND operation is 0 means partial visible line is there. So perform the computation like this. Find out the midpoint. So when partially visible line is there, then you have to find the intersection point of the line with edge, and it is computed by recursively subdividing the line at its midpoint. Right? The same procedure we have studied. First midpoint, M1, having the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. Again, compute the outcode of M1. M1 चा outcode check करायचा, whether M1 is inside or outside. Then if it is inside, then perform that recursive division. Okay, so these are the steps. First, read the dimensions of the window, draw the clipping window. Second is read the endpoints of the line, draw the line. Third is find the outcode of the line and check whether it is accepted, rejected, or partially visible. So up to this step, it is same, and only this step is different. In the else part, that means for a partially visible line, divide a line into two halves at midpoint and recursively call the step number 3. That is, for every midpoint also you have to check the end code and repeat this procedure till you get the intersection point of window and the line. जोपर्यंत लाईन आणि विंडोचा इंटरसेक्शन पॉइंट मिळत नाही तोपर्यंत तुम्ही रिकर्सिव्हली मिड पॉइंट पर्यंत डिव्हाइड करत राहणार आहे. Okay, so that was the algorithm and the example that we will see in the next lecture. So we will stop here for today. Students, give me attendance. Roll number 1. Roll number 2.
Present, ma'am.
Roll number 3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6, 7, 8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, okay, 14. Yes, 13, I have put your attendance. Roll number 14, not there. 15,
Present, ma'am.
okay. So we will stop here for today. Thank you.